In our last lesson, we learned how we can extend one class and then gain the benefit or code reuse by taking the methods that we don't need to alter and using them in our current class. Today we're going to learn another level of code reuse that we can leverage to again shorten our code and maximize code reuse. So if we go all the way back to our coin class and we look at these methods and we ask ourselves which of these methods are essentially identical across all of the classes that we've made, or at least which of them are close enough that they could become identical. Let's take a moment and look at the D6 class and look at the randomize method. Notice that the randomize method uses math.random multiplied by the number of sides on the die. Coin essentially does the same thing. Coin essentially does the same thing, but because there's only two sides, we don't multiply times anything. And then if we look at a polyhedral die, we have what is in fact the version that could be used for almost all of the methods. Now, if we look at our equation here, we're using number of sides here, but really we could use the method getPossibleOutcomes to give us the number of sides, and we could use that as a way to come up with a randomized number for all of our classes. But some things are different in all of our classes. For example, we really can't say what getCurrentFace should look like for coin versus for a six-sided die or a polyhedral die, or certainly not for a labeled polyhedral die. So we can't really write that code. However, Java has a system for dealing with situations just like this, where you can write some code but not all of the code for a class. And if we go back and look at our randomizer interface and review what an interface is, an interface has declared methods that have no code. There's no instance variables and there's no code. What we're going to do now is we're going to create a new class that is going to be in a special category, and we're going to make this an abstract randomizer is the name of our class. We're going to click finish. Okay, now we're going to add a new keyword in front of this class, but let's first put it in our java.comments to describe what it is we're going to do. So this class will serve as the basis for most, if not all, of our other randomizer classes. It will include some code, but leave some methods undefined. And that's what makes it abstract, is that it will have some things that are not defined. So again, we're going to put our name, and we're going to add a version, 2015, and then we'll just get rid of that blank line, and we're ready to go. So because this class is going to have some undefined methods, it means that this is not a class that we could ever instantiate, and thus it is a special category of class called an abstract class, which is why I put the word abstract in the name to help remind us. So this is an abstract class. An abstract class shares some things in common with an interface in that it will never be instantiated. However, it is different because it will have some methods defined, and it will also have some instance variables. And then also it is going to implement the randomizer interface. Okay, so my abstract class is first keyword abstract, second it's going to implement the randomizer interface. So what is an abstract class? An abstract class is a class that can never be instantiated. It may have instance variables and some methods defined while leaving other methods to be defined later. Okay, so what does that look like? Well, what can we say about all randomizers that they're all going to have in common? Well, we need something to keep track of which side is up. And even though in the coin we made that a Boolean, we could have just as easily made it an integer. So what we're going to do is we're going to make one that's the same for all of them. We're going to call it private int side up. And then we're going to define the rest of the methods that are in our interface. So we're going to go back to our randomizer interface, copy our methods into our abstract class, and now, I should put instance variables. Okay, so now we're going to define these. So, get possible outcomes. Do we know how many possible outcomes there are going to be for each different type of randomizer? And the answer is we don't. So we can't write a get possible outcomes method because we have nothing to keep track of how many outcomes there are. So we're going to say public abstract, or actually we can put abstract in front. If we spell it correctly, abstract public int get possible outcomes. And notice when I did that, the little error box went away because Java says, okay, well, this is an abstract class, therefore you're allowed to mark a method as being abstract, which means that it is undefined currently. Okay, then I'm going to have get current value. Well, get current value is one of those few methods that we can actually define because the current value is always the side that's up. So we can just say return side up. Okay, now get current face, well, that is going to be very different for each class. So again, we're going to mark it abstract, and that allows us to not have to write that code in. All right, and that leaves our setters or mutators. So now we're going to say, can we write the randomize method? And this is where it gets interesting. We can say that side up is equal to, we're going to use our casting as an integer, and then we're going to put something inside here, or an expression. Once again, it's going to be based on math.random. And we're going to multiply it by something. Well, how do we know what to multiply it? And this is where things get interesting because we're going to multiply it by get possible outcomes as a method. Now, you say, but get possible outcomes is abstract. Remember, this class here is never actually going to be used in its current condition. What's going to happen is we're going to extend it and we'll fill in the missing methods, at which time this will become defined and this statement will make sense. So I'm going to say that, and then I'm going to add 1. So it always falls in the range of 1 to whatever it is that I'm defining. So if it's a two-sided die, like a coin, it'll have the values of 1 and 2. If it's a six-sided die, it'll have the range of values of 1 to 6. Okay, now there's one other method that I could fill in if I wanted to, but again, we don't want to define something we don't need to, and that's going to be different for each one, and that would be the toString method. So basically, we're done. We've defined all of the methods that are in the interface, except that we've actually left two of them as being abstract and only defined truly two of them. Okay. So now how do we use this? Well, let's go first back to our coin and see what we would need to modify. So in our coin class, instead of implementing randomizer, we can simply extend an abstract randomizer. And by extending an abstract randomizer, we're going to automatically get certain things. Well, what are we going to get? The first thing that we're going to get is that we already have an instance variable that's going to keep track of which face is up. So then all we have to do is write our constructors, and our constructor isn't going to change. So we're just going to shorten this code because these notes were left way back when we first started, and by now you guys know all of this. And then we're going to have get possible outcomes. Now, did we leave get possible outcomes as an abstract method? And certainly we did, which means in coin we must define it. So we're going to return 2. Then we have get current value. Well, did we already have a get current value? And we did, so we simply delete get current value because we don't need to redefine it. Now keep in mind this will alter the behavior of a coin slightly from the way it originally worked. We said tails had a value of 0 and heads had a value of 1, and if we do this, we're basically saying that tails is going to have a value of 1 and heads will have a value of 2. All right. Now, we have to rewrite our get current face because notice get current face was left abstract. That means it isn't currently defined, and so we must define it. So we're going to say here for our if condition, is heads no longer exists, but what does exist is get current value. And what should it be equal to if we have a heads? And the answer is 2. So if get current value is equal to 2, we're going to return heads. Otherwise, we're going to return tails. And then, does this method need to change, our toString method? No, it gets to stay the same. And then do we need to write a randomize method anymore? Well, no, we don't, because we have that method already written from abstract randomizer. Notice that abstract randomizer gets possible outcomes in order to calculate the random value, but we've now written a get possible outcomes, so now it can do its job correctly. And look, see how much shorter the code is when we write it this way. And more importantly, all of our various classes that we've written so far should get shorter when we do this to them. Okay? All right, well that takes care of coin. So now let's switch over to our dice bag runner and let's modify our dice bag runner so that we can put lots of objects into our dice bag and roll them. So we're going to do this. We're going to say we're going to create a dice array of randomizers filled with null values of type randomizer. Okay, and we're going to make 5 of these. We're going to make our first one a coin. So we're just going to say here that we're going to instantiate some randomizers. Instantiate instantiate. There we go. Some randomizers. So our first one's going to be a coin. I'm going to delete these comments. Then our second one is going to be a D6. Our third one is going to be a polyhedral die using our default constructor. Then our third one will be a 12-sided polyhedral die. Then our fourth one wait a minute, I've got coin, D6, polyhedral die, 3, and our fourth one will be a labeled polyhedral die using our default constructor. And you know what? We're going to have to add one more to our dice bag. So we're going to have 5 will be a polyhedral die with a set number of sides. So we make our randomizers up to 6 here. Okay. And if we run our code here, we should see that even though we've completely rewritten our coin class, our code should still work exactly the same way. The coin is showing heads, heads, heads. And we can see that it's still working in exactly the same fashion. So everything looks good. So it looks like we're ready to move on. So what are we going to do next? Well, next we're going to want to rewrite our D6 class. So that will be for the next lesson.